Hi, this is Kaylee, and we are going to work on ray tracing or geometric optics, either way you want to call it. But today we're going to start off with a concave mirror. A concave mirror is, well, caved in the center. It's pushed in the middle. And so in this case, we're talking about spherical concave mirrors, which would make a big old circle, a sphere, if it went all the way around. And we need to mark a couple of locations on this. And so right here, that is what's called the focal point. So we'll just call it F. And over here, which is twice the distance out, this is the center of curvature, or sometimes we call it the radius of curvature, where C is equal to twice F. We measure all distances from the mirror. And this is one branch of physics that you can leave things in centimeters and it's perfectly fine. Or we can convert it to meters. Doesn't make any difference. But we traditionally use an arrow as our object, so we can tell whether our image is pointing up or down. To actually figure out where the image is, we need to draw some lines. And there's a bunch of them that you can do. I'm going to focus on really just 2 or 3 and show you how that you can use just simple lines to figure out where the image of this object would be in reference to the mirror in the original object. So, to start off with, if you remember this mantra, parallel, focal point, parallel. You need at least 2 rays to locate the image. And you can use 3 if everything's drawn to scale. If they're not, then just stick with 2. But parallel focal point will work pretty much any time. You don't need anything special for it, besides having these points marked. So, as it says, we're going to start off all our drawings from the top of our object. So from the top of this arrow, that's our object right over here. Okay. And we are going to draw a line straight across. So remember, the mantra is parallel focal point. So any ray of light parallel to this principal axis, which is our big dark line through the center of everything, is going to go until it hits the mirror. So I want to try to use this. It hits the mirror right there. And where it hits, you stop, and it's going to reflect through the focal point. So it should reflect down this way. And I'm using solid lines because this is where the light would really go. The light could project back. Those would be virtual rays, but we don't really need them for this picture. But parallel, and then through the focal point, and the beam of light would go off in that direction. So that's parallel focal point. The next one is focal point parallel. So, as the statement suggests, we're going to start off at the top of the object and go through the focal point until we hit the mirror. And so we should go from here through the focal point until we hit the mirror. Then after we hit the mirror, it should reflect parallel to the principal axis this way. See, they cross right here. As soon as we get 2 reflected rays that cross, that's where our image should be. So our image should be right here. And since these came from the top of the arrow, they make the top of the arrow. So that should be the top of the arrow right there. And since the bottom of the arrow is on the principal axis, the bottom of the image is on the principal axis. So the image should be right there. And we can do a check by doing a third ray. The third ray is one that's a little bit harder to do. You have to be a little more picky with it, because what it does is, if we draw a line from the top of the object to where the principal axis hits the mirror, oh, we got pretty close. And then it should reflect back off. So let's see, we're 1, 2, 3, 4, 1, 2, 3, 4. So I'm not using a protractor. I'm going to use that as an estimate. And so they all should intersect pretty much right there, which is not bad. Got pretty good. Now, for properties of this image, well, for one thing, you see that it's upside down. Okay, so it's inverted. And it's also real because that is actual light that's being reflected off. So if we put a screen right there, we can actually show an image of that upside down arrow on the screen. All right, let's try another one as we move this object in. So that was the object outside C. The image is in between C and F. Now, fourth ray that you can draw is lining up to the center curvature. Center curvature, that would be the radius curvature. That would be where it would make a sphere all the way around this point. So if we go from here through the top of the object through the center curvature, and this carried itself on out, that beam of light would come through, hit, and then bounce right back off. And so all three should cross at the same point. So that's a fourth ray that you can draw. Almost left that one out. All right. Okay, so now let's try one where the object is at C. So we're going to do the same thing. Parallel, focal point, parallel. So starting off at the top of the object. Right there it is. We draw a line parallel. If I can get everything set up properly. Parallel to the principal axis until it hits our mirror. And then it's going to reflect off through the focal point. That's what we call it the focal point. That's what we call it the focal point. That's why we call it the focal point, because any beam of light that comes in parallel to the principal axis will reflect through that point. So that can give you a good hot spot. Now, for focal point parallel, start off at the top of the object, draw a line through the focal point until it hits the mirror, and then it's going to reflect parallel to that principal axis. I'm off just a little bit. So my image is right here. Now, if I did everything perfectly, and I'm trying to see which one I messed up on, probably that blue one not exactly going through the focal point. My image for this one looks like it's right here. Really, it should be right under C. If the object's at C, the image should also be at C. So I'm just a little bit off on my focal point where they cross. See, I'm a little bit ahead of it. So if I pull that back, this should drop down. It should cross there. But in any event, let's see. We got 3 up, 3 down. It's about the same size. So that's not too bad. So again, it's upside down. So it's inverted. It's real because those are actual light. And if I drew it perfectly, then it should be the exact same size as the image. So that's 3 blocks up. This is 3 blocks down. And it should be right up and below the object. So it should be right there. It wasn't too bad. Let's see as we progressively move that object in. So now we've moved the object inside C. So now the object is in between C and F. And we're going to repeat our parallel focal point. Parallel. It's the mirror. And then it should reflect through the focal point. Actually, I'm going to go ahead and draw that further out just in case. See if I can repeat that. Not bad. Okay. And then now focal point parallel. So line up the top of the object with the focal point. Draw a line from the top of the object through the focal point till it hits the mirror, and then it reflects parallel. Make that a little bit darker. And where they cross, that should be where the image is. So it should be right here. And now if you look at this one, again, it's upside down, so it's inverted. It's real, because that's actual beam of lights that come back. We can project it onto the screen. And it's much larger. If you compare the other ones, if you looked at the first one, the image was actually smaller than the object. Then it was at C, object and image are about the same height. And now that we're inside C, now the image should be larger than the object is. So as we move this in, the image moves out and gets bigger. But what happens if we're inside that focal length? So what's the difference here? Well, we can do a couple of different things. So I want to start off, we can do a couple of things very similar. We can still do parallel focal point parallel. Start off the top of the object, which is a little high on this one, and go through the focal point as normal. Now, because I know what's going to happen, I'm going to draw dotted rays coming out the back, and I'm going to go all the way out because I don't know how far this will go. So that's a real beam of light. That's a virtual beam going this direction. That's parallel focal point. Now let's do focal point parallel. Now, obviously, since we're inside the focal point, we can't go from there to the focal point to the mirror because that's going the wrong direction. But what you can do is line up the focal point in the top of your object and draw your ray from the top of the object until it hits the mirror. And then it's going to reflect parallel. It's going to reflect off this direction. But if we look, that line and that line never cross. But if we draw that virtual ray behind, it does cross behind the mirror. And because it crosses behind the mirror, well, it's going to be right side up. It's going to be larger than our object. And it's going to be virtual. I really should have drawn that as a dotted line, but I wanted to make sure it showed up. On the image. So this is right side up, or sometimes you call it erect. It is virtual. Again, I should have made this dotted lines to represent virtual. And it should be larger. Now you can always use the other two rays as well. You don't have to just use parallel focal point parallel. But those are some of the easiest ones to draw. But any of them should work as long as you get two that cross. Thank you, and tune in again. But remember, if you want to draw these rays, you only need two. So parallel through the focal point parallel will work really easy, and all you need is a ruler and to know where the focal point is. All right, thank you, and tune in again, and we'll do some convex mirrors.